All right, here we go. Welcome to Friday. Go ahead and get out your homework. All right, hopefully you guys did okay with this. I didn't get any emails, anybody asking me questions, so I assume that means we did good. All right, here we go. So it's 2 through 26 evens. Number 2, the answer is 56. 56. Number 4, the answer is 15. 15. Number 6, the answer is 6 root 10. So 6 times the square root of 10. Number 8 is 10. Number 10 is 7 root 5, 7 square root 5. Number 12 is 99 root 2. Number 14 is just root 2. If you put root 2 over 1, yeah, that's right. Number 16 is 1/2. Number 18 is root 2 over 3, so the square root of 2 divided by 3, or over 3. Number 20 is 2. Number 22 is root 55 over 11. So square root of 55 divided by 11. 24 is pretty ugly, but 20 root 13 all over 13. And the last one, number 26, is 2 root 10. 2 root 10. All right, count up how many you got wrong. Put that as answer number 1 on the Google Forms. Here's your calendar. Remember, Monday is an off day. You will not receive any emails on Monday from any of your teachers unless you specifically need help. Most of the teachers, obviously, we're in the same boat as you guys. We're at our homes, so I would be more than happy to help you out on Monday. But you won't get any work scheduled for Monday. So we'll pick it back up on Wednesday, Friday, and then that'll do it for the year for new instruction. And then that following week, we jump right into semester final review. Remember, your finals actually do start that week on Friday. Will be your English final. It's a 3-day weekend for Memorial Day on that Monday, and then we'll pick up on the rest of the finals for Tuesday, Thursday, and or Tuesday, Wednesday, Thursday, Friday. So Tuesday is your science final. Wednesday is your Latin final. Thursday is your math final. And Friday is your history final. So just remember, even though we're going to do semester final on that Monday or semester final review on that Monday, Wednesday, it's going to be a full week, right, until that Thursday of the following week before you take your test, your math semester final. So my word of advice is, work on that Monday, Tuesday, Wednesday, or maybe at least review the class on Wednesday, and then on that Thursday of that third week there, I would start working on your English final. Make sure you're ready for it. You're the captain of your boat, so study as much as you need. And if you have any questions, make sure you ask your teachers. All right, here's your homework for tonight. You're going to like today's homework. All right, so let's see. Previous class we did multiplication and division of radicals, square root symbols. Remember, radicals is for everything, even though this year we're only going to be dealing with square roots. And today we're going to be doing adding and subtracting. All right, last class we did multiplication. So today we're going to be doing adding and we're going to be doing subtracting. All right, adding and subtracting radicals. And remember, once again, we're only going to see square roots this year. Algebra 2, you'll start seeing cube roots. We will not see cube roots at all in geometry next year. Pre-algebra, we saw cube roots. And strangely enough, in Algebra 1, we don't deal with cube roots at all. We will see them in higher level roots as well as we go forward from Algebra 2 onward. All right, so let's get to adding and subtracting radicals. Good news for you is there's only one rule. It's pretty simple. All right, you're going to like this. So write this down, please. To add or subtract like radicals, I'll explain that here in a second, you simply add or subtract their coefficients. That's it. That's the whole darn rule. So if the radicals are like, and by like I mean what's underneath the square root symbol is exactly the same, right? If you have what's underneath the square root symbol the exact same number, turns out you can add or subtract them. How do you do that? You look at their coefficients. So in this case, what's underneath the square root symbol here is b, right, for both of those terms right there. Therefore, I can't add these. So all I do is add their coefficients, whatever a plus c is. That's the answer, times the square root of b. Same thing for subtraction. As long as what's underneath the radical symbol is the same, right? You can subtract them. All you do is subtract the coefficients. A minus C times the square root of B. Yeah, it literally is that simple. Let me show you an example. You simply need to make sure that what's underneath the radical symbol is exactly the same. So I got the square root of 7 and the square root of 7. I can add and subtract these. It tells me to add, so all I do is add 4 plus 5. Now, do you really need to write the step that I just write? Oh, obviously not, but you do need to obviously write the answer. Okay, the rule for addition is the same as for subtraction, but you must ensure that what's underneath the radical symbol is the same. Notice I have square root of 11. I've got square root of 11 on the second term, so I can subtract these. So all I do is subtract the coefficients. Do I need to write that step? Well, if you need to, sure, but most of us would simply say 4 minus 8 is negative 4. Okay, so that's starting to make sense? It's pretty easy, right? There's always a but, and the but is this. If what's underneath the radical symbol is not the same, notice I've got the square root of 3 and the square root of 6. Clearly, 3 is not the same as 6. So you can't add these. In fact, you can't do anything with these. So that's the answer. In other words, that's fully simplified. Okay? Yeah, that's a pretty big but. But there's an even larger but. And the even larger but is this, right? Sometimes you have like radicals and you won't know it. You're like, well, wait a minute, what do you mean there? I mean, look at this problem right here. I've got the square root of 3 and the square root of 48. Well, clearly, 3 is not the same as 48, but it turns out the 48 is 3. What do I mean by that? Well, we can simplify the square root of 48. Remember, a couple lessons ago, the square root of 48? 48 can be written as 16 times 3. The square root of 16 is 4. 4 times 5 is 20. So it turns out they are like radicals. They're both the square root of 3. It's simply that the other one wasn't fully simplified. So this is a very large but here. You have to make sure that before you decide, oh, they can't be added or subtracted together, that you've simplified all the radicals in the problem. Okay? Oh, by the way, what's the answer here? That's right, 24 root 3. Now that second to last step there, I'm going to have that throughout the class here today. I certainly don't expect many of you to actually write that step down. Okay, so let's do some examples here. Here we go. Let's do some together. All right, first one on the left. Allie, you want to try that one? That's right. So we have like radicals. 3 plus 2 is 5. Adding the coefficients, so we get 5 root 5. Right? Probably a poor example to use because it gives you the impression that the coefficient and the radical number are exactly the same. How about we do the middle one there, McKinley? What do you got there? This is actually a bit more challenging. No. What? Oh, yeah, that's right. That's right. So remember, the coefficient in front of that second one is a 1. So that's 4 root 7 plus 1 root 7. We just choose not to put that 1 there. So this would be 4 plus 1, which is 5. Let's see if all my answers are 5 here. All right, last one. What do you got, Ben? That's correct. 2 minus 6 is negative 4. So we get negative 4 root 10. Now, one thing that we did not do there was to ensure each time we did those problems that we're dealing with like radicals. So just make sure that's your first step. Your first step should be, do I have like radicals? If the answer is no, then your second question is, well, are they fully simplified, right? If they're fully simplified and they're not like radicals, then you can't do anything with them, right? But if they're not fully simplified, you simplify them and then go back to the same question. Now, do you have like radicals? And if the answer is yes, you may certainly add or subtract them. You add or subtract the coefficients. We good? All right, so go ahead and try these on your own. Answer the question number 2 on the Google Forms. Now, notice you don't have a square root symbol, so I want you to write, for instance, if it was 5 root 3, you would write 5, R-O-O-T, root 3, okay? How'd you do? Well, remember, the first step is always to ensure that you have like radicals. So on the left there, let's see, root 2. So like radicals, we add the coefficients. 4 plus 2 is 6, so we get 6 root 2. The middle one there, we haven't done one like that, right? So let's see what we get here. So let's see, 4 root 7 minus, so we have like radicals, square root of 7. So let's see, it would be 4 minus 4. Well, that's 0. Well, remember, this would say 0 times square root of 7, and then anything times 0 is 0. So we get the answer 0 there. How many people got that one? The last one, let's see, what do we got? Root 3. So we got like radicals. So we can subtract minus 2, minus 6, same signs. So negative 8 root 3. We good? Okay. We need to do some more challenging ones. All right, some more challenging. All right, so here we go. Ooh, look at this. So we got 3 terms that are being added and subtracted. Now remember, you can only, in algebra, you can only add like terms. So which ones are the like terms? Well, let's see, we got the square root of 6, the square root of 13, the square root of 6. So clearly the square root of 6 are like terms. Is the square root of 13, can you reduce that? Right? You always have to ask that question, right? In this case, no, there's no perfect square in the square root of 13. So that one's fully reduced or fully simplified. So I'm gonna group together like terms. So the 3 root 6 and the plus 5 root 6 could be grouped together because those are like terms. Now I'm not suggesting that you actually do this step right. I'm writing right here. I'm just showing you what I'm doing. All right, so I can add those two together. I can't subtract the 2 root 13 not like term. So let's see. 3 plus 5 would be what? 8. So we get 8 root 6 minus 2 root 13. So once again, we can't do anything with that square root of 13 because it's a 13 and the other one's a root 6. So they're not like radicals. Make sense? All right, let's do two challenging ones together. All right, let's do the one on the left here. So what I said is you can group like terms together. In this case, we have the square root of 14, the square root of 14. Is that fully simplified 14? Is there any perfect square that goes into 14? Because maybe it's root 3 just in disguise. No, there's no perfect square that goes into square root of 14. So all I'm going to do is, well, they're already next to each other, so I don't need to regroup them. So let's see. 8 root 14 minus 5 root 14. 8 minus 5 is 3. So I get 3 root 14 and then the square root of 3. And it looks weird, but remember, square root of 14 and the square root of 3 are not like radicals, so you can't do anything. This next one, though, look at it. Check it out. They're all the same, right? They're all the square root of 17. So we can group all of those coefficients together. Now, we can't do all the math together. Now, remember, we got to go from left to right. But we're only dealing with the coefficients here, since every one of them is the square root of 17. So 6 minus 5, just go from left to right. 6 minus 5 is 1, and 1 plus 3 is 4. How many people beat me to that answer? Okay, good, you're catching on. There are far more challenging ones. These are going to be the most challenging ones that we'll do. We're only going to do, I don't know, 3 of these, so make sure you pay attention. All right, it's not more challenging because there's 4 of them. It's more challenging because, check it out, I got the square root of 3, the square root of 6, the square root of 48, and the square root of 54. Inside that 48 and 54 are some perfect squares. You have to always be ready to simplify those square roots. So I can't do anything with the square root of 3 and square root of 6, not like terms. The square root of 48, yeah, I can rewrite 48 as 16 times 3. And I can rewrite 54 is 9 times 6. Now 16 and 9 are perfect squares. Pause if you need to wrap your head around what I just did. Rewind it. Okay. So let's see. The square root of 16 is 4. 4 times 2 is 8. The square root of 9 is 3. 3 times 6 is 18. So make sure you understand where I got that 8 and that negative 18 from. See what I did there? But now look at the radicals, right? Now I've got 2 root 3s and 2 root 6s, so I can group those together. Okay, so I'm going to group together the root 3's, their coefficients, and I'm going to group together the root 6's, their coefficients. So let's see, the root 3 coefficients, that would be 7 plus 8. You see where I'm getting that? 7 plus 8 for the root 3's. How about for the root 6's? That's negative 4 minus 18. I just rewrote all that together. So here's an example where, yeah, you might want to do this step, right? Try not to do this one in your head, right? There's just too much going on there. Okay, so let's see. 7 plus 8 is 15. Negative 4 minus 8 is negative 22. Wow, that was a lot of work there. If you need to hear that again, pause, rewind, play that again. Or just pause and look at the numbers and make sure you understood where I got all of those numbers from. Yeah, this is the most complicated one. Let me flip to the homework real quick. Um, there are, oh, I don't know. There's only a couple like this. In fact, I don't see anywhere we're doing anything with four terms together. But there's plenty that were three that you actually do have to simplify the square root symbols before you realize which ones are like terms. All right, last two, last two. All right, we need to do these together just to make sure we're all on track. All right, let's see. The first one on the left there, we got square root of 3, square root of 75. Clearly not like radicals. However, inside of 75, there's a perfect square. What's that perfect square? All right, 25. I can write 75 as 25 times 3. This should be becoming a bit more intuitive now that you're looking at these numbers, you're recognizing the perfect squares. All right, the square root of 25 is 5. 5 times 2, right, the coefficient. 5 times 2 is 10. So I get 10 root 3 for that one. Hey, look, now I have like radicals. Okay, 5 plus 10, that's right. 15 root 3 is your final answer. Okay. If you want to pause the video and get to the answer before I do, please go ahead. All right, last one. Last one. So I got the square root of 7, square root of 14, not like terms, not like radicals. There's no perfect square in 14. But the other one, the 28, there is a perfect square. What perfect square is in 28? That's right, 4. 4 times 7 is 28. So I'm going to write 28 is 4 times 7. The square root of 4 is 2, and 2 times 5 is 10. All right, now do we have any like radicals? We certainly do. Root 7. So I've got 10 root 7 plus 2 root 7. 10 plus 2 is 12, so I get 12 root 7. Unfortunately, square root of 14, we got no friends for you to group with. You are socially isolated for us today. All right. Well, there you go. Hey, that wasn't too bad. These are, I don't know, maybe I'm weird, but I find these a little bit fun. All right, so here's your homework. If that didn't make sense to you, please email me. I'd love to give you any assistance you need. If not, go ahead and get your homework knocked out. And let's see, today's Friday, so I'm not going to see you on Monday. You can email me on Monday. You can, C-A-N, email me on Monday for help. That's cool. If not, then I will see you guys on Wednesday.